Let's continue with the discussion. Okay, so we were discussing about similar triangles. Let's do the first exercise. Just a moment.
Ma'am, I'm sorry I'm late.
Just a second. Yes. Hi, Salva. How are you?
Hi, ma'am. I'm good. How are you?
Yeah, I'm also good. Okay, so you was not there in the previous class. Let me give you a brief on what is similar triangle. Yes, Amir and Arfa. Let me give her introduction. Then I am continuing with the chapter.
Yeah, oh yeah,
But
sure,
teacher, I
ma'am.
joined the previous class.
Yeah, you was not there in the previous class, right?
Which one? The first class I attended.
See, similar triangle we had started over here. Let me give just the introduction I had given, nothing else. Okay. Quickly, I'll be able to cover it. Listen to me carefully. Salwa, this is especially for you. Okay. So be careful. You are
Okay,
not
ma'am.
missing any point. Yeah. So you can see we are having a rectangle over here, ABCD, on the right side of the screen, and another
Yes,
rectangle,
ma'am.
PQRS. Okay, we are
Yes.
checking these two figures are similar or not. First, we are trying to understand what is the meaning of similarity. Okay, so we are finding here the length of the side, there the length of the sides are given. Angle over here is known, angle over there is known, because these two are rectangle. For rectangle, we know each interior angle will be 90 degree. Okay, now we are checking the ratio between the side. AB by PQ, you can see we found the ratio as a 1 by 4. This one. Okay, one of the side from here we have taken, another side from there we have taken, and we have just found the ratio. Now the second side from here, the second side from there we took, and we found the ratio as a this BC we have taken from here, and this QR over there we have taken, and we got still the ratio is 1 by 4. Now we took CD from here, and we took RSSR from there, and still we got the ratio as a 1 by 4. And the fourth side we have taken from here, fourth side we have taken from there, and still the ratio is 1 by 4. So two such figure where the sides will maintain same ratio just like this, and angle will be same. Okay, each interior angle over here will be same with interior angles over there. That means corresponding angles will be same. Just like congruency, here also the angle will be exactly same. But I am not saying sides will be same. You can see sides are not same. The ratio between the sides are same. So this type of figure is called similar figure, where the sides are maintaining same ratio and angles are same. Okay, you can see the second
Okay.
figure. Here also we are having two triangles. We have found the ratios between one of the side from here, one of the side from there. The ratio is 1 by 3. Another ratio we have found, one of the side from here, one of the side from there. Ratio is 1 by 3. Okay, again we have checked the ratio between the third side over here with the third side over there. Again the ratio is 1 by 3. Now
1
one
by
of the
3.
angle over here, one of the angle over there is same. Second angle over here, second angle over there is same. The third angle over here, the third angle over there is same. Hence, these two figures are similar with each other. Similar figure doesn't mean that exactly same. Similar figure means the shape will be same. That means we will be comparing triangle with triangle. But the ratio between the sides, that will be same and the angle will be same. That means if we are having a teeny tiny triangle MNO, we are stretching it. We are stretching it, and we are stretching it in such a way that this side 2 centimeter became 6 centimeter. That means 3 times. Can you see? 3 times 2, 3 times
Yes,
6.
ma'am.
We are stretching it in such a way that 3 centimeter became 9 centimeter. 3 times. Okay, 3 times 9. And we are stretching it in such a way that this 4 centimeter became 12
Became
centimeter.
12.
Again 3 times. So by maintaining proper, okay, proper measurement, like each and every time, each and every side we are doing 3 times, 3 times, 3 times, that way we are stretching by maintaining the angle same. Okay, doing while making this teeny tiny triangle as a huge big triangle, the angle is not getting changed. That means here 30, there 30, here 70, there 70, here 80, there 80, the angle is not getting changed. And that's how these two shapes are similar shapes. Making sense?
Yes, ma'am.
Yes, ma'am.
Okay. So first you need to understand the meaning of similarity. If you got what is the meaning of similarity, now we were discussing that if we will take any two square, any random two square, we have taken two square ABCD and PQRS. Okay, square means
Okay.
here the side I have taken as a 10 centimeter and there I took the side as a 28. Or maybe here I took the side as a 5 and there I took the side as a 6. 5 centimeter, 5 centimeter, 5, 5, because it's a square. They are 6, 6, 6, 6. Now we found the ratio between the side, and can you see every time the ratio will be same?
Same. Yes,
Why?
ma'am.
Because it's a square. Why? Because it's a square.
Square.
Getting it?
Yes, ma'am.
Okay.
Hmm.
And each interior angle we need to match for declaring that these two shapes are similar. So the moment I have declared these two are square, each interior angle has to be 90, right?
Yes.
That's why the conclusion that any two square are always similar with each other. Any two square, instead of 5 and 6, I could have taken 15 and 16 and still the ratio will be same. Is it making sense?
Yes, ma'am.
Similarly, just keep it in mind, this rule. Any two squares are always similar. Any two squares are always similar with each other. Now the next rule is this one. Just like a square, any two equilateral triangle is always similar. Okay, here you can see we have taken two equilateral triangle. One is smaller, another is bigger. Doesn't matter at all because we are not checking ditto same, exactly same. Okay, here the side is 28, 28, 28. The other sides are 13, 13, 13. And can you see when we will find the ratio, it will be same. When we will find the ratio, it will be same. Yes or no?
Yes.
Yes, ma'am.
Just a moment. Hence the conclusion that any two equilateral triangle are always similar. Again, the angle is also same. Ratio between the side is same, but the angle is also same. Can you see?
Yes, ma'am. 60.
Okay, since it is equilateral triangle. And then for circle also, any two circles are also always similar because we don't have anything is circle. The measurement is only the radius. So radius over here, radius over there, radius over here, radius over there, radius over here, radius over there. Always it will be 3 by 7, 3 by 7, 3 by 7. Yes or no?
Yes.
Okay,
Hmm.
that's why we see an angle also. Here the complete circle, the complete angle will be 360. There also the complete angle will be 360. So for circle, you take any two circle means you take any measurement for two circle. Okay, those two circle definitely will be similar. Clear?
Okay, ma'am.
So two squares are always similar with each other. Two equilateral triangle are always similar with each other, and two circles are always similar with each other. Clear so far?
Yes, ma'am.
Now the fourth rule, that if a figure is congruent, then those figure will definitely be similar. If two figures are congruent, that means ditto, same, exactly same. If two figures are congruent, then the moment you will find the ratio, you need to find the ratio this way. 5 by 5 ratio is 1 by 1. 6 by 6 ratio is 1 by 1. 7 by 7 ratio is 1 by 1. Can you see? When it is ditto, same, exactly same. And the angles also. Okay, one of the angle over here, one of the angle over there will be same. Another angle over here, another angle over there will be same. The third angle over here, the third angle there will be same. So angles matching and the ratio we are able to check. Okay, these two figures are congruent figure. Why? Because one of the side here, one of the side they are matching. The second side here, second side they are matching. The third side here, the third side they are matching. Angle here, angle they are matching. Second angle matching. The third angle matching. Can you see these two figures are congruent?
Yes, ma'am.
But here we are, what we are saying, that these two are similar also. Congruent also, similar also. Why? Because it is fulfilling the similarity condition. The ratios are coming same. Can you see?
Yes, ma'am.
So there is the last rule, that any two congruent figure will always be similar.
Must be
Any
similar.
two congruent shape will always be similar. Clear?
Similar. Yes, ma'am.
Now you should have clarity in your mind that similarity means rule number 1. Sides must be in proportion. This proportion means same ratio. Okay, and angles must be same. Clear? Better we write corresponding sides must be in proportion. Corresponding angle must be equal. Clear? So far, any confusion? Anyone?
No, ma'am.
Okay, now let's do exercise question. Today itself we'll be proving basic proportionality theorem. Can you see the first exercise?
Yes.
All circles are
Similar. Similar.
all
Similar.
squares are
Similar.
all dashed triangles are similar.
Equilateral. Equilateral.
Equilateral triangle. Two polygon of same number of side are similar if their corresponding angle are
Equal.
and corresponding sides are
Proportional.
proportional. Proportional means maintaining same ratio. Is it clear so far?
Yes, ma'am.
State whether the following quadrilaterals are similar or not. We can check the ratio between the side, but we can see the angles are not same. Okay, here the angle is 90°, but here not. Can you see?
Yes, ma'am.
So we don't need to check the ratio. If the angle is not matching, why we will check the ratio? Clear?
Yes,
Okay.
ma'am.
These two are not similar. Is it clear?
Yes,
Now
ma'am.
today we are going to discuss basic proportionality theorem known as Thales theorem given by the mathematician Thales. The name of the mathematician is Thales. Okay, basic proportionality theorem we are going to discuss today. First you need to understand this theorem, then we will be doing the proof over here. Maybe today's class completely will be taking for this proof, and the next class, okay, we will be doing it until or unless it will be clear to all of you. So here let's try understanding the theorem first. So if a line is drawn, the theorem number 6.1, if a line is drawn parallel to one side of a triangle, you are having a triangle, let's say triangle ABC. If a line is drawn parallel to one side, how many sides are there? AB, BC, CA. AB, BC, CA. Okay. If a line is drawn parallel to one side of a triangle, maybe the line looks like this. To intersect the other two sides in distinct point, you are drawing a line in such a way that this is parallel to one side of a triangle and intersecting the other two side at two distinct point. The other two side, it is touching, intersecting at two distinct means different point. Can you see that?
Yes, ma'am.
Yes, ma'am.
Okay, the other two side are divided in the same ratio. Then the other two side are divided in the same ratio. That means AD by BD is equals to AE by EC. If
Easy.
parallel, then the ratio will be same. If parallel, then the ratio will be same. If you are having a triangle, let's say the triangle is PQR. If there is a line which is parallel to one of the sides, suppose parallel to PQ, you are having a line like this. Okay, this line is not a random line. This line is touching the other two side at two distinct point. This line is touching the other two side at two distinct point S and T. Then your other two sides are getting divided in the same ratio. That means this RT and TP, whatever ratio this is maintaining, the same ratio will be maintained by RS and SQ.
Yes.
Making
Yes, true.
sense?
Yes, ma'am.
Okay, if you are having a triangle, in that triangle, if there is a line parallel to one of the side, not mandatory that it will be parallel to the horizontal line. We take it always parallel to horizontal, but the parallel can be anyway. Okay, the line which is parallel in a triangle, three sides are there, and you are having a line which is parallel to one of the side. Suppose parallel to this side, you are having a line like this, like this. Name of the triangle, you can say MNO. This black color line is intersecting the other two side at two distinct point. Let's say P and Q. Then your other two side MN and NO. MN and NO is getting divided in equal ratio. That means NP by PM, that is equals to NQ by QO. Making sense?
Yes, ma'am.
While
Yes,
taking the
ma'am.
ratio, please be careful. You have to take the ratio in the same sequence. That means from there you are starting with N to P. So here you will take the upper part first, N to Q. Okay, here and there taking the ratio is not allowed. I mean mixing the ratio is not allowed. NP, PM. There also NQ, then QO. Don't take QO by NQ. Getting it?
Yes, ma'am.
Yes, ma'am.
Okay. The rule says if parallel, then the ratio will be same. If parallel, then the ratio will be same. If you are having a triangle, in that triangle, if there is a line which is parallel to one of the side, then the ratio will be same. The moment you notice parallel, then you can quickly say the ratio will be same. That's what we are going to prove. Since it is parallel, hence the ratio will be same. Clear?
Yes, ma'am.
Okay, let's do it.
Yes.
To prove this theorem, you need to understand first few things. Okay. So suppose we are having a triangle. We have not started the proof. Okay. You need to understand few concepts, then only we can prove it. Suppose you are having a triangle ABC. Now I want to find the area of this triangle ABC. If there is a perpendicular given over here, I mean an altitude given over here, BD, then can you tell me how to find the area? Suppose this is 5, this is 8, this is 7, and this complete side is 6. How to find the area? Yes, how to find the area?
By adding the exterior angles first.
1 by 2 into base into height. Area. Area of the triangle. 1 by 2 into base into height. Yes or no? Right? Do you know this formula for finding the area? Yes, Arfa?
Yes, ma'am.
Yes, ma'am.
Okay, 1 by 2 into base into height. Now I want you to tell me that which one is the base and which one is the height. 1 by 1. Abdullah, what you are thinking? What is the base? What is the height? In this triangle, which one is the base and which one is the height?
Ma'am, AC is the base, BD is height.
Exactly. Perpendicular, which is dropped, that is the height. BD is the height. Okay, BD is the height, and this height is, we have dropped the height, or the height is getting dropped on the side AC. So this is the base. You all understand Hindi?
Yes, ma'am.
Salwa?
Yes, ma'am.
ओके
Yes.
जब भी हम किसी ट्रायंगल के बेस और हाइट की बात करते हैं तो सबसे पहले हाइट का मतलब होता है परपेंडिकुलर. ओके किसी वर्टेक्स से क्या कोई परपेंडिकुलर ड्रॉप्ड है. ओके तो वो होता है हमारा हाइट. यहाँ पे क्लियरली दिख रहा है बीडी ऐसा वैसा लेंथ नहीं है. दिस इज द 90 डिग्री परपेंडिकुलर ड्रॉप हुआ है. ठीक है तो ये रहा हमारा हाइट. और ये जो हाइट है कौन से साइड के ऊपर फॉल कर रहा है? एसी के ऊपर. तो वो रहा हमारा बेस. जरूरी नहीं है कि हॉरिजॉन्टल साइड को ही हम बेस बुलाते हैं. जरूरी नहीं है कि जो हमारा ऐसा जो ग्राउंड लेवल या फिर जो हॉरिजॉन्टल लाइन हो उसे ही बेस बुलाते हैं. बेस का मतलब हॉरिजॉन्टल लाइन बिल्कुल नहीं होता है. बेस का मतलब होता है जिस साइड के ऊपर ऑल्टीट्यूड ड्रॉप्ड है उसे बेस बुलाते हैं. अगर ऑल्टीट्यूड ऐसे ड्रॉप है तो हाँ ये रहा हाइट और ये रहा बेस. अगर हमारे ट्रायंगल में सेम ट्रायंगल में अगर पिछले एग्जाम्पल की तरह ऐसे हाइट ड्रॉप्ड है तो ये रहा हमारा हाइट और ये रहा हमारा बेस. और अगर मैंने इस वर्टेक्स से हाइट ड्रॉप कर दिया लाइक दिस 90 डिग्री, तो फिर ये रहा हमारा हाइट, और जिस साइड के ऊपर ये हाइट फॉल कर रहा है उसे बुलाते हैं बेस। आ रहा है समझ में?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
ओके, हाइट और बेस, एक ट्राइंगल का एरिया निकालने के लिए हमारे पास 3 वेज होते हैं। इस फॉर्मूले 1/2 इंटू हाइट इंटू बेस वाले फॉर्मूले से हम जब भी एरिया निकालते हैं, हमारे पास 3 वेज होते हैं एरिया निकालने के, या तो फर्स्ट वे या सेकेंड वे या थर्ड वे, जो यहाँ पे मैंने ड्रॉ करके दिखाया है। ओके, अब अकॉर्डिंगली हमें जो डेटा हमें प्रोवाइडेड होता है, जो डेटा हमें गिवन होता है, हम वैसे एरिया फाइंड कर लेते हैं। बट इसका मतलब ये नहीं है कि ये तीनों वेज से जब हम एरिया निकालेंगे तो हमारे एरिया डिफरेंट डिफरेंट आ जाएंगे, ऐसा बिल्कुल नहीं है। ओके, ये 3 वेज हमें सेम आंसर देंगे एरिया का। आ रहा है समझ में?
Yes,
Yes,
ma'am.
ma'am.
एरिया का
Yes,
आंसर
ma'am.
कभी चेंज नहीं होगा, क्योंकि हम सेम ट्रायंगल की बात कर रहे हैं। 3 वेज हैं एरिया निकालने के, लेकिन एरिया का वैल्यू सेम होता है। ओके, हम अकॉर्डिंग टू द डेटा प्रोवाइडेड हम एरिया निकालते हैं हमेशा। बट इन केस अगर हमें सारी डेटा एक ट्रायंगल ड्रॉ करके और सारी ही डेटा प्रोवाइड कर दी जाए, इसका मतलब है जैसे भी एरिया निकालो एरिया तो सेम ही आना है। अगर तुम्हें एक ट्रायंगल ड्रॉ करके और ये भी हाइट बता दिया जाए, ये भी हाइट बता दिया जाए, और ये वाला हाइट भी बता दिया जाए, और इस साइड की लेंथ भी बता दी जाए, इस साइड की लेंथ भी बता दी जाए, और this side's length also will be given, then अब हमारे ऊपर डिपेंड करता है कि हम कौन सा वाला हाइट और बेस लेके एरिया निकाल रहे हैं। अगर किसी स्टूडेंट ने एक तरीके से निकाला, दूसरे स्टूडेंट ने दूसरा वाला हाइट और बेस का पेयर लिया, और तीसरे स्टूडेंट ने थर्ड वाला हाइट और बेस का पेयर लिया, तीनों के आंसर सेम आएंगे। आ रहा है समझ में?
Yes, ma'am.
Yes, ma'am.
ओके, क्योंकि हम सेम ट्रायंगल की बात कर रहे हैं। नाउ अगर ये पार्ट क्लियर है तो हमें ये भी समझने की जरूरत है कि हमारे पास जब भी हम ट्रायंगल में परपेंडिकुलर ड्रॉप करते हैं, देखो हमारे ट्रायंगल में कितने वर्टेक्स है? 3 वर्टेक्स। इस कॉमन पॉइंट को हम वर्टेक्स बुलाते हैं, इसे हम वर्टेक्स बुलाते हैं, इसे हम वर्टेक्स बुलाते हैं। तो वर्टेक्स, किसी भी एक वर्टेक्स से हाइट ड्रॉप करा जा सकता है, हमें पता है, राइट? राइट, किसी
Yes,
भी एक
ma'am.
वर्टेक्स से हाइट ड्रॉप किया जा सकता है। हाइट का मतलब होता है 90 डिग्री। तो किसी भी एक वर्टेक्स से स्टार्ट करके ओके 90 डिग्री ड्रॉप करना, उसे हम हाइट बुलाते हैं। अब कभी कभी ऐसा भी होता है कि अगर हमने एक हाइट, हमारे पास एक ट्रायंगल है, कुछ ऐसा दिखता है, एबीसी ट्रायंगल। इस ट्रायंगल में जैसे ही मैंने वर्टेक्स ए से हाइट ड्रॉप करा, ए से, तो हमें रियलाइज हो रहा है कि ये जो हाइट हमने ड्रॉप किया, ये जो परपेंडिकुलर लाइन हम ड्रॉप करने की कोशिश करें, ये तो ट्रायंगल के बाहर लाई कर रहा है। और ऐसा तुमने मे बी पहली बार देखा
Exterior.
होगा, या फिर मे बी यू ऑलरेडी हैव सीन सच सिनेरियो। बट दिस इज कंप्लीटली नॉर्मल एंड कंप्लीटली एक्सेप्टेबल। कभी कभी ऐसे ट्रायंगल हो सकते हैं जिनमें किसी एक वर्टेक्स से हम 90 डिग्री ड्रॉप करने जाएं और पता लगे कि वो 90 डिग्री ट्रायंगल से बाहर लाई कर रहा है। दिस इज कंप्लीटली नॉर्मल सिचुएशन एंड कंप्लीटली एक्सेप्टेबल। अगर ऐसा हमारा ट्रायंगल है तो हमें एरिया निकालते वक्त ध्यान से देखना, अगर ऐसा ट्रायंगल है तो हमें एरिया निकालते टाइम this AD length we have to take, height will be the length AD and base will be BC। क्यों BC? क्योंकि इस BC को ही एक्सटेंड करने, the moment we are extending this BC, it is just we are able to connect it with the AD। तो हमें एक्सटेंडेड लेंथ नहीं लेना होता है, हमें हमारे ट्रायंगल का साइड ही बेस लेना होता है, बेस। Okay, this is the base and this is the height. Is it making sense? Why we are saying BC is the base? Because BC को extend करके height से हम meet करा पा रहे हैं। आ रहा है समझ में?
Yes.
Yes, ma'am.
Yes, ma'am.
Is it clear to all of you?
Yes, ma'am.
So far, any confusion? The height of the triangle can lie outside the triangle. In such scenario, we should not panic. This is completely normal, completely acceptable. We can have such triangle. Here the height we need to take AD. Okay, just and the base we will be taking BC. Why BC? Because the moment we are extending the side BC, we can see now the height is falling on this side. So we will be taking the original length of the like one of the sides, that is BC. Is it clear?
Yes,
Yes,
ma'am.
ma'am.
Let's move. Now, if this much is clear, then just a moment. Yeah. Area of the triangle, we write it this way. Area of triangle ABC. There is a shortcut also to write the same thing. We can also write the same thing as AR, area, and in bracket we'll be writing ABC. ये दोनों एक ही बात है. Okay, this one is the shortcut and this one is the long form. Both are allowed in mathematics या both are allowed. क्या हम fair portion में कभी हमने ऐसा लिख दिया तो marks कट जाएंगे? बिल्कुल नहीं. आ रहा है समझ में?
Yes, ma'am.
Yes, ma'am.
Okay, now let's start with the proof. हमें क्या प्रूफ करना है कि अगर हमारे पास एक ट्रायंगल है और उस ट्रायंगल में किसी एक साइड के पैरेलल एक लाइन है, okay, and this line is intersecting the other two sides at two distinct points. Okay, then the ratio, the two sides are getting divided in the same ratio. That means side AB और side AC same ratio में divide हो रहा है. ये जो line DE है, AB साइड और AC साइड को सेम रेशियो में डिवाइड करेगा. मतलब हमें ये प्रूफ करके दिखाना है कि the ratio AD by BD is equals to AE by EC, and given it is given in the question that DE is parallel to BC. Clear?
Yes,
Yes,
ma'am.
ma'am.
Let's prove it. Is proof. For proving this one, we need to keep in mind one construction. The whole proof you don't have to memorize. I'm telling you, you have to memorize the construction part. Do you have to memorize it? Yes, you have to memorize the construction part, that there is a construction which you have to keep in mind. Okay, so we are going to do the construction. We will be joining B with E and D with C. Okay, joining B and E as well as the vertex C and D. Okay, and two more constructions are there. We will be dropping the perpendicular from the vertex E like this, and we will be dropping the perpendicular from the vertex D as well. Just a moment, let me take the name according to the book. So this one we can call M and this one we can call N. Now I'm not telling you to copy anything from here, because today you just need to focus, just look at the screen and try understanding it. Okay, so what we have done, we are having a triangle ABC where we know parallel is given. We are having a triangle ABC. We know parallel condition is given, and we have to prove the ratio is same. For that we have to do construction first. Construction means we will be joining B with E, we will be joining C with D. Apart from that, we will be dropping one perpendicular From the vertex E, we will drop a perpendicular, and altitude we will draw over here. Okay, and we can call it N. And from the vertex D, we will drop an altitude over here, and we will call it M. So far, is it clear to all of you?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, the construction and everything. Now, just focus. We want to prove the ratio same. We want to prove this ratio AD by BD. Here the numerator is AD. Okay, the numerator is AD. So we want to take such a triangle where AD must be there. हम ट्रायंगल के एरिया को यूज करके ये पूरा प्रूफ हम क्या करने, कैसे प्रूफ करने वाले, एरिया यूज करने वाले. जस्ट अ सेकेंड. या हम ट्रायंगल के एरिया फॉर्मूला की हेल्प से इस पूरे प्रूफ को कंक्लूड करने वाले हैं. हियर व्हाट वी आर गोइंग टू टेक, जस्ट इस एडी को ध्यान से देखो. प्रूफ में हमें क्या चाहिए, एडी. न्यूमरेटर में क्या है, एडी. अब हम हमारे फिगर में आते हैं और देखते हैं एडी कहाँ है. कैन यू सी एडी?
यस.
हमें एक ऐसा ट्रायंगल लेना है जिसमें एडी होना ही चाहिए. ओके, तो हम एडीई ट्रायंगल चूज करेंगे. कौन से ट्रायंगल हम चूज कर सकते हैं, एडीई. हम एरिया ऑफ द ट्रायंगल एडीई वी विल बी टेकिंग, एंड वी विल बी राइटिंग 1/2 इंटू बेस. बेस हमारा एडी होगा, एंड इस बेस के ऊपर ऑलरेडी हमने कंस्ट्रक्शन करते वक्त हाइट ड्रॉप करा है, तो हाइट हमारा en होगा. क्या सबको समझ में आ रहा है?
यस मैम.
ओके, कहाँ से हमने एडीई ट्रायंगल लिया, जो हमारे प्रूफ में एडी बाई बीडी है. सबसे पहले हमने प्रूफ वाले न्यूमरेटर को ध्यान में रखकर ट्रायंगल पिक करा है. ऐसे अगर ध्यान में हम नहीं रखेंगे, हमें बहुत कंफ्यूजन होगा. इस पूरे फिगर में बहुत सारे ट्रायंगल दिखेंगे और हम ढूंढते रह जाएंगे कौन से ट्रायंगल को पहले लेना है, कौन से ट्रायंगल को बाद में लेना है. ध्यान से देखो, प्रूफ में सबसे पहले एडी है, तो हमें ऐसा वाला ट्रायंगल लेना है जिसमें एडी होना ही चाहिए. ओके, तो ध्यान से हमने कौन से वाले एडीई ट्रायंगल लिया, और इस ट्रायंगल में हमने 1/2 इंटू बेस इंटू हाइट. ओके, बेस हमने एडी लिया एंड हाइट हमारा en है. हाइट और बेस पे हमें कोई कंफ्यूजन नहीं है, राइट?
यस.
Yes, ma'am.
अब हम डेनोमिनेटर पे फोकस करने वाले हैं. यहाँ हमारा डेनोमिनेटर बीडी है. अगर हमने इसे ध्यान में ना रख के ऐसे ही जस्ट ढूंढने की कोशिश की अब कौन सा ट्रायंगल, तो फिर हमें बहुत कंफ्यूजन हो जाएगा. बेस में हमारा बीडी है, डेनोमिनेटर में बीडी है. हमें अब ऐसा ट्रायंगल पिक करना है जिसमें बीडी साइड इंक्लूडेड होना चाहिए. ध्यान से देखो, हमें एक ऐसा ट्रायंगल पिक करना है जिसमें बीडी साइड इंक्लूडेड होना ही चाहिए. तो बीडी साइड के साथ तुम्हें दो ट्रायंगल दिखेगा. एक रहा ये ट्रायंगल, और दूसरा
Triangle
This-
BDE.
या here we need to take BDE triangle. क्यों? क्योंकि हम खुद से और कोई कंस्ट्रक्शन यहाँ पे नहीं करने वाले. अगर हमने ये ग्रीन वाला ट्रायंगल पिक कर लिया, ओके, BDC, तो बेस को BD तो हम ले सकते हैं, बट क्या यहाँ हमें कोई हाइट दिख रहा है, कोई परपेंडिकुलर ऑल्टीट्यूड ड्रॉप दिख रहा है BDE ट्रायंगल पे? बिल्कुल नहीं.
No, ma'am.
और अब हमें कोई कंस्ट्रक्शन करना अलाउड नहीं है. ऑलरेडी स्टार्टिंग में हमें जितने भी कंस्ट्रक्शन करने थे हमने कर रखे हैं. अब इसके उस प्रोसेस के बाद हम कहीं भी कोई हाइट ड्रॉप नहीं करने वाले. तो ग्रीन वाले ट्रायंगल में हमें कहीं ऑल्टीट्यूड नहीं दिख रहा है, हम ग्रीन वाले ट्रायंगल को नहीं लेंगे. ओके, वी विल बी टेकिंग द अदर ट्रायंगल दैट इज BDE. अब ध्यान से देखते क्या BDE में हमें ऑल्टीट्यूड दिख रहा है. तो अगर ध्यान से देखोगे तो तुम्हें समझ में आएगा कि हाँ, एक ऑल्टीट्यूड है जो ट्रायंगल के बाहर है, और ऐसा सिचुएशन मैथ्स में कंप्लीटली नॉर्मल होता है. हाँ या ना?
यस.
Yes, ma'am.
ओके, तो BDE ट्रायंगल में वर्टेक्स E से एक ऑल्टीट्यूड जाता हुआ हमें दिख रहा है. वर्टेक्स E से एक ऑल्टीट्यूड, एक परपेंडिकुलर ड्रॉप होता हुआ दिख रहा है जिसका नाम en है. ओके, दिस इज कंप्लीटली नॉर्मल. हम कौन से ट्रायंगल लेने वाले हैं, ट्रायंगल BDE. एरिया ऑफ द ट्रायंगल BDE विल बी 1/2 इंटू बेस. बेस हमें BD लेना ही चाहिए क्योंकि हमें रेशियो फॉर्म करना है. ओके, और हाइट हमारा इस बार भी en आ रहा है. ध्यान से देखो, तुम्हें खुद समझ में आएगा that yeah, we are on the right track. Can you see 1 by 2 gone, en gone, ad by bd we will be getting? Yes or no?
Yes, ma'am.
Okay. तो हम रेशियो को ध्यान में रख के एक एक स्टेप परफॉर्म करेंगे, कोई कंफ्यूजन नहीं होगा। इस पूरे थ्योरम में हमें क्या याद रखना है? कंस्ट्रक्शन। नेक्स्ट, अब हम रेशियो, द अदर साइड वी आर गोइंग, हियर वी आर हैविंग AE वी आर हैविंग ओवर हियर। अब ध्यान से देखो, हमें ऐसे ट्रायंगल पिक करना है जहां AE होना चाहिए। AE अगर हमें AE चाहिए एज अ बेस, ऑफ कोर्स एज अ बेस, ओके, then we can again take AED triangle. Okay, let's take AED triangle. 1/2 base is AE, and on this base, can you see a height DM? Can you see a perpendicular DM?
Yes, ma'am.
Okay, now the last denominator, focus, EC. अब हमें एक ऐसा ट्रायंगल चाहिए जहां पे EC has to be one of the side. We want to take EC as a base. While finding the area, we want to take EC as a base. Here also you will see two triangles. Where EC is included, you will find two triangles. See, one is EBC. Can you see EBC triangle?
Yes, ma'am.
But here there is no altitude, there is no height, and I am telling you that in between we are not allowed to do any construction. Okay, already all the construction part we are done. Okay, so we cannot take EBC, we will be taking the other one, that is ECD. Can you see ECD? You are having a triangle ECD.
Yes, ma'am.
Okay, and in this ECD, from the vertex D, a perpendicular is dropped, which is lying outside the triangle, and this is completely normal and acceptable in mathematics. Yes or no?
Yes, ma'am.
Yes, ma'am.
Okay, so we will be taking area of the triangle ECD. Is equals to 1/2 into base is EC, into height is again DM. From here you will feel that the moment you will find the ratio 1/2 gone, DM gone, AE by EC you will be getting, which you want to prove. Yes or no?
Yes,
Yes, ma'am.
Okay, so till here it should get registered in your mind in today's class. We are almost done, but the next part I'll be telling you in the next class. Today you need to make sure that this much you are able to do quick in the rough part all by yourself, that there is a triangle ABC. Okay, there is a line which is parallel to BCDE. Okay, and you have to prove the ratio same. Which ratio? AD by BD is equals to AE by EC. This is called basic proportionality theorem. This is called Thales theorem. Okay, now for that you need to do one construction. The construction you have memorized really well. You are joining D with C, you are joining B with E, you are dropping the perpendicular from the vertex D like this, and you are calling it M, and you are dropping the perpendicular from E, you are calling it N. Now quick, you are saying the AD is there, AD. Now you are going to take a triangle where AD you want to take as a base, AD you want to take as a base. So area of triangle ADE is equals to 1/2. Base is AD, which you want to take, and on this base there is a height, that is EN. Any confusion so far?
No, ma'am.
Then you are seeing the denominator over here is BD. You are going to take such a triangle where BD needs to be there. You will find two triangle with the base BD, but okay, you have to pick BDE triangle, because BDC triangle, if you will take, there is no height, no altitude. Okay, you don't know anything. So BDE triangle, if you will take, then you will find that the altitude in BDE triangle is lying outside the triangle. in BDE triangle, if you are taking this triangle, then here there is a perpendicular which is lying outside the triangle, and this situation is completely normal, completely acceptable in mathematics. So you are going to take 1 by 2, base is BD and the height is EN. Clear?
Yes, ma'am.
Okay, now again you are seeing the other side of the ratio. AE is there. Accordingly, you are picking the triangle AED. There, AE is the base. You want to take AE as a base. AE as a base. So you will be taking AE as a base, and on this base, DM is the height, right? Right?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Okay, now you are looking at the denominator EC and you are checking EC. Okay, so again with EC you will find two triangle, but one of the triangle will not have any height or anything. So you need to pick this triangle, the green one. Here you will find that yeah, there is a height which is lying outside the triangle, and this is completely normal, completely acceptable in mathematics, and you will be taking area of triangle DEC. That is equals to 1 by 2 into base is EC into height is DM. Any confusion so far?
No, ma'am.
Now
No.
you will be calling the first one as a equation number 1, the second one as a equation number 2, the third one as a equation number 3, and the fourth one as a equation number 4. Now you will be doing the division of equation 1 and 2. You will be doing the division of equation 3 and 4. Let's do it. Why? To make the ratio. Okay, to make the ratio, you need to divide equation 1 and 2. You need to do the division like this. Now, in the next class, we'll be doing everything properly. But today, my motto is to make it clear to you. Okay, fix it in your mind so that just everything will be there in your mind. In your rough part, you are able to do this much thing all by yourself. Okay, fair portion I'll be showing you in the next class. So please make sure that these things are clear to you, and don't just copy. Yeah, you can write it, but fairly properly we'll be doing it in the next class. So 1 divided by 2 area of triangle ADE, okay, divided by area of BDE, that is equals to 1 by 2 into base into height over the other triangle 1 by 2 into base into height. You will find that en gone, 1 by 2, 1 by 2 gone, and the ratio you are getting AD by BD. Other side also, 3 divided by 4, you are having area of triangle AED over area of triangle DEC. For AED, we were having 1 by 2 into AE into DM. And for DEC, we were having 1 by 2 into EC into DM. DM gone, 1 by 2, 1 by 2 gone. So we are left with AD by BD over here and AE by EC over there. Any confusion so far?
No, ma'am.
No, ma'am.
We are almost done. Okay, we are almost done. Just one more concept and we will be done. But I want you to do this much by yourself and check it. Are you able to do it till here by yourself? Starting from making the triangle, doing the construction, okay, writing what you have to prove, and then writing the 4 areas and then doing the division. Are you able to do this much? Then I'm going to tell you how to do the final, just how to write the final step, because there also one concept we need to